Alright guys, today we'll talk about the chain rule. It's a very helpful rule in calculus, and it is represented as this. That is, when we take the derivative of a function y with respect to x, we can actually take the derivative of that value of the function y with respect to any other variable, say z, and then we multiply it by the derivative of that function that we have assumed with respect to x, that is d of z by dx. Alright, so this is actually equivalent to cancelling out z from here and there, and we end up with this value again. Now this is correct because dz is same as h. We simply represent it in this manner, that is, it's a very small value. But many a times we also think of this to be an operation. So operation, right? So it may not seem very intuitive to actually cancel out the term dz, because we may think it is a part of the operation. So it's like cancelling out sine of x and sine of, say, x squared. So we actually cancel out the value sign. This is right, this is wrong. Alright, and if people simply think of this as an operation, we cannot do so. But in fact, it is not really purely an operation, because these represent individual values and we are simply dividing them. At times we have to assume this to be an operation, because indeed when we apply this to any variable, say y, it actually gives us another value. It's like taking the sine of that angle. Alright, so it indeed acts as an operation and also does not. Alright, it depends on where we think of it as an operation. Here, when we do apply the chain rule, we do not, and it works fine. Now, where should we use the chain rule? Well, it gets handy when we have a function like so. So when we have y is equal to e raised to the power this quadratic polynomial, which would be 2x squared plus 3 times x. Alright, so if this is the function and we have to differentiate it with respect to x, then we actually first of all differentiate it with respect to this polynomial itself, and then we differentiate this polynomial with respect to x. That is the same thing that we have done here. We differentiate it with respect to the polynomial, and then we differentiate the polynomial itself with respect to x, and we multiply both of them. Alright, so I'll state the chain rule again, and here I assume the z, the variable z, to be equal to this. So this is what I've got from here. Alright, and z is actually equal to, and what I have assumed it to be equal to, is 2x squared plus 3x. Alright, now the thing is, I have to differentiate this. Now to make it more easy to understand, I have replaced this with z, and I've written it here. So it's actually, so the derivative of this value would be equal to the derivative of e, because y is replaced with e to the power this value, so it would be e to the power z. Alright, and I take the derivative with respect to z first of all, then I take the derivative of z with respect to x. So I can evaluate this individually, and I can evaluate this individually, and I can multiply the product. And this is why it is helpful, because I know individual of these derivatives, that is, individually I know what these end up to, and so I can multiply them. But if I don't use the chain rule, it becomes really difficult for me to think about it alone. Alright, so this is equal to this, that is the derivative of e to the power any variable with respect to that variable itself always gives us the same term, that is e to the power the same variable. This is a very fundamental property of this function. This is known as an exponential function with the base e, not with the base e, but we assume it. Right, so e is a special value, and when we take the derivative, it ends up with the same value. Alright, now we multiply this, that is, we consider the second term, and we actually can take the individual derivatives of these terms and add them, and we do so. So derivative of x squared would be equal to 2 times x, and derivative of x would be equal to 1. So I multiplied 2 with 2 and x, and 3 with 1. So I end up with 4x plus 3. I've copied this as it is. And finally, I have to replace z because z was not asked or was not stated in the question. This is the question and did not really give us what z should be. So we have to state our answer in terms of x itself. And when we do that, we have to replace z with x. That is, we have to write z in terms of x. And that is simple because we have already made that. We had assumed it ourselves, so it's simple. Alright. And therefore, the derivative of y with respect to x, that is the derivative of this function, the derivative of this function would be equal to d by dx of this function itself, that is e to the power 2x squared plus 3x, should be equal to, or in fact is equal to, e to the power, this value, that is the polynomial itself, multiplied by the derivative of the polynomial with respect to x, which is 4x plus 3. So this gives me the derivative of this complex function, and this is how the chain rule helps. Thank you.